Okay, for this exercise we're going to be making a game which was originally called Breakout in the arcades. You might know it by the name Brick Breaker on your mobile phone. So basically you control a bat that moves around the bottom of the screen and you try and hit a ball that should hopefully hit a bunch of bricks and get you points. If you miss, the ball goes past you and you lose a life. So this is going to be a Breakout clone. Give it a slightly original name. But it's still a mono game for Windows Project. Now last time we made a sprite class and we put it straight into the game 1 class, so it was like a subclass within there. This time I'm going to do it slightly differently. We'll right click and add a class directly to the project, and let's call it Sprite. So this time your namespace, there's another line that gives you access to the same namespace that your game itself is in, but it's for a different code file and it's got different contents. In this case it's just the Sprite class, so I'll enter the same kind of stuff that we had before. Remember to make them public if you want to be able to access these member attributes from other places than this one code file. If you don't do that, they'll default to private, and the only place you will have access to them is in this one code file. You know what, I should probably resolve them or I'm going to keep having that problem. Okay, so this should look familiar. It's the same stuff we had in the Sprite class before. It helps if you can type. Oh, proper camel case. Okay, now we also need some collision response in here. The sprite should be able to respond to collision with other objects. I could type this whole method out again, but I think what I'll do is I will look for the file we did before. And that was the first portfolio project. Here's game 1 for it. You can open up different game 1 files. If you do that, be careful that you know which one you're working on. It's very easy to get them mixed up. If you're not sure, you can just double click the one on the right hand side and it'll take you to the one that is definitely the correct one for this project. But in the meantime, we do have access to our previous game, the Pong game, and there's our bat collision. Let's copy that over to the new Sprite class. And obviously it won't just work straight out of the box. Let's close game 1 down so we don't get confused. Put that inside the Sprite class. You see the indentation there? So there's no point calling it bat collision because it's now a collision between any two objects, which will bounce one object off the other. And that's a lowercase s. You know what, I'm going to change it here. That'd be easier to work with. And we don't know for sure that it's going to be a bat and a ball. In fact, one of these two sprites is going to be the sprite that we're already, I guess you could say, inside. So we should take one of these sprites away, rename the other. That's going to be our target sprite. Let's rename ball sprite to target sprite. You know what, that might be better done the other way around. We'll rename the bat sprite to target. And take the ball away. So how's that going to work? We only have one sprite now. Well, we don't. We also have the second sprite, which is our sprite, the one we're actually dealing with. So this is our sprite, this sprite, and that is the target sprite. So what do we need to change? Well, we don't need... Actually, we don't need this at all, this part here at all, because that if statement, we're going to let the game itself deal with that. So take that out and take out the curly bracket that goes with it. Let's fix the indents. It's only the collision response. We're not doing the actual collision here, so we don't need a sound effect either. We're going to just do anything that says ball sprite. We're just going to assume it's this sprite. So we'll take out the word ball sprite, and it should have access to the direction, the position, the previous hitbox, etc. for the current sprite. So ball sprite comes out from all these places. And we renamed the other one to target, so that shouldn't need fixed. By the way, I hope you noticed in the last one that I missed a minus sign here, and it didn't really matter because the bat was on the left hand side and you couldn't hit it from the on the right hand edge. But when you put the second bat in, you could have. Easy mistake to make. Right, has that fixed everything? Seems a little too easy. We'll probably come back to that if something goes wrong. But now every sprite has a method called bounce off. So if you tell a sprite to bounce off a target sprite, that should be what happens. See a little asterisk that's a sprite.cs, that means it hasn't been saved. I'm going to do Control S just to save that. Don't really need to, because it should save every time you compile. But if you have a slight bit of OCD, that might make you feel better. Okay, so now we're actually going to look at game one where we can use this sprite. We'll start with some basic sort of bookkeeping stuff. In your initialize, we're going to set the graphics. Holy heck, how did that happen? The preferred back buffer width. And the preferred back buffer height. Don't forget to apply those changes. And let's position the window in the top left corner of the screen, the monitor. Just some basic stuff to get us going. Now we'll also need a texture for the background to our game, and that texture will need to be loaded. So go to load content, take out the to do reminder, because that's what we're going to do right now. Don't leave in to do comments. It's sloppy. Okay, so background image equals content.load, and we're loading a texture 2D called, well, I haven't actually got one yet, so but I'm going to assume that I'm going to call it breakout background, and then draw it. There's another to do reminder. I'm going to replace that. Sprite batch, the lowercase s, that's the object, not the class. Sprite batch.begin, sprite batch.end, and then between them, sprite batch.draw. What are we drawing? Well, we're drawing background image, and I'm not going to use a rectangle this time. I'm going to hope that our image is the right size. Draw it in dark blue because it's a sort of cloud effect. Now might be a good time to load in the content. Sometimes this will happen when you open up the pipeline editor that doesn't actually load a pipeline. So we have to click open, make sure we go to the right one. Break content. Right, now we can add to that pipeline. And what I'm going to add is a bunch of content that I made earlier. Font, some music, some sounds, some graphics. Let's copy them all over. And don't forget to close down so that it saves it, and it will compile all of the content. Hopefully, if I've spelled everything right, it should run and load a background image and do nothing else. Come on, any time today. There we go. That's what I meant by a cloud. Okay, so the next thing we want, I'm going to start with a ball. So we can say sprite here because it's in the same namespace. It knows that sprite is a thing that exists. Sprite ball equals new sprite. So I've constructed a sprite. There's nothing in it yet though. So let's go to load content. Say sprite dot not sprite dot ball dot image. So we're accessing the image within the ball. And we're going to load a texture 2D called breakout ball in this case. We'll give it a position, which I will calculate from the graphics device viewport width divided by 2, so halfway across the screen is where I'm going to position the middle point of the ball. That's what that second part's for. So graphics device viewport height divided by 2. So you know what, I'll do times 2/3, so it's 2/3 of the way down the screen it should spawn out. So that's your spawn point for the ball, and its initial direction will make it not exactly a 45-degree angle, just slightly off, for making it slightly more interested. And those two lines we're going to repeat every time we respawn the ball, so let's refactor it by extracting it into a method called spawn ball. We can now reuse that when we like. I'll minimise it just now. What next? I guess we can draw it next. So we're going to draw the ball image in the ball's position with the correct tint according to the ball. I won't run it just yet because I'm going to add some update logic. Take that comment out. Ball.position, it's going to increment by its direction. You know what, let's just go ahead and also add in a little bit of logic for the edges of the screen. If the x goes below 0, then the x direction is multiplied by -1. It's reversed. Notice that I put the consequent on the same line as the condition, and that's alright. That's called an inline consequent. It's allowed. It's a little bit iffy sometimes, but if we've got a lot of if statements that are similar, it might be worth doing it that way, because the y is basically the same. And also the x on the right hand side, but instead of greater than 0 it'll be greater than graphics device viewport width minus ball image width. The fourth if statement, when the ball position along the y-axis goes past the bottom of the screen, I'm going to add in, I don't know if I need to add in the height, probably not, but just to let it go a little bit off the screen before we respond. If it goes off the bottom of the screen, we want to lose a life. We don't have lives yet, but we also want to spawn the ball. Let's run that. Good stuff. Fairly predictable though, but it's a start. That's our ball. Next we have the bat. So sprite bat equals new sprite. Load in the image. I bet you saw that coming. We're probably also going to want to respawn the bat at some time, so let's add in a spawn bat call, but that doesn't exist yet, so let's fix that by generating it. There's made spawn bat. Spawn bat will crash it by throwing an exception, so let's take that out and put in some code to make it actually spawn a bat, which I guess is just going to give it a position. New vector 2, graphics device viewport width divided by 2 minus bat image width divided by 2. Again, positioning the middle of the image in the middle of the screen. As for the height, graphics device .viewport .height, the bottom of the screen, minus the bat image height, so we bring it back on screen. And you know what, I'll put in a 10 pixel margin as well. And just to be safer, I'll set the direction to 0, so if it happens to be moving when it respawns, it should stop moving. And draw the bat, don't forget that. Draw the bat image in the bat position with the bat tint. See that? It's there, good. A little higher up than I thought it would be, never mind. We need to get moving next. If the keyboard status tells us that a key is pressed down to go left, then we'll respond by accelerating in the direction of the x-axis, or negative x-axis I suppose, to the tune of 1 pixel per frame acceleration. Which may not sound like much, but that quickly adds up. And the same for keys right, except obviously the direction will be positive. Don't forget to modify, or to integrate I should say, because that's what we're doing, integration. Integrate the direction into the position. We'll also throw in some friction. I really need to comment these a bit more. And stop it from going off the screen. Position goes below 0 on the x-axis, then really? Then position on the x-axis returns to 0, so it doesn't go past that. But also, direction will become 0, so that it doesn't maintain any velocity when it hits the side of the screen. Similarly, on the right hand side, if it goes past pixel number, well, it's worked out by graphics device dot, did I spell that wrong? Graphics device dot viewport dot width minus BATIMS dot width. You should be seeing the way these things work by now. If that happens, then we set the bat position dot x to be that. Bat direction, on the other hand, still becomes 0, so it's not moving any further. Direction and position must be kept separate, of course, but it's easy to mix them up in the heat of the moment when you're typing a lot. Right, I think that'll let us move around. We won't have any collisions yet though. No. To help us with collisions, let's deal with some hitbox stuff in the sprite class itself. So there's a sprite class, it's got a bounce method. Let's add in, why is that private? Maybe we should make that public now, so we can access them from elsewhere. The hitbox is going to be updated by the sprite itself when it's told to, and the way we'll do that is first we'll set the previous hitbox to be hitbox, so that it stores where it came from. You could do this another way using Verla integration, but that's a bit more advanced. In the hitbox itself, we're going to set the x coordinate to be an integer version of position.x, because position is made up of two floats, and the y is going to be an integer version of position.y. The width of the hitbox is the same as the width of the image, and the height of the hitbox is the height of the image. Fairly simple, but let's us use that code for our bat or ball and all 40 bricks without having to replicate it. So now that our bat has moved, let's say ball.update hitbox and bat.update hitbox. Once those hitboxes have been updated, we can ask if the bat hitbox has intersected with the ball hitbox. And if it has, then the ball will bounce off the bat. This is where I'll find out if I got that the right way around, I suppose. Let's watch that in action. Nice. Does it do the sides? Yes, it does. Excellent. Right, so that's the bat and the ball. Let's add in our lives variable next. Lives go down when it goes off the bottom of the screen. That was here. So as well as spawning the ball, lives, decrements, goes down by 1. We need to display that somewhere, so let's put in a sprite font. And we load it. That's in the content, of course. You'll need to add one if you don't have one yet. And draw string using that font. What are we going to draw? We're going to draw the word lives followed by the actual lives variable. I'm going to draw it at position 5,5 on the screen, and let's go with light blue. Try that out. 0 lives, it'll go down to -1 when it respawns, but it does work. Code's getting a little bit messy. Let's use the outlining tool. We'll collapse it all so we can see a bit easier what's going on. And the update is probably the worst culprit. There's lots of stuff in there, so let's refactor it. We will put the gameplay. It's everything that makes the game actually happen. The ball moving, the respawning, the bat intersection, all of that. Pretty much everything except for one line above and below. We'll extract that into a method called something along the lines of update gameplay. So we have an update which updates the whole program, and then update gameplay which updates the gameplay. Why would we bother doing that? Well, when you run out of lives, you're going to go to a different screen and you'll no longer want to update the gameplay. So we want to make that optional without it being unwieldy. Well, let's do the same in draw. This is all to do with drawing the game itself. Extract a method, draw gameplay. Okay, now we need to know whether we're going to draw that screen or not. That can easily be a boolean, whether the game is over or not. And it will start with, well, I think we'll start with true. A lot of old arcade cabinets would always say game over in between games. Now what we need to do in the update then is say if game over is not equal to true, then we update the game. So if it's not game over, then you're playing and you play the game. Another way of doing that, by the way, a shorter way, is just to say not game over. You can do that, that's fine. I think there's also a shortcut. Can you right click and surround with if statement? I don't know if you find that easier or not. Oh, that's the wrong kind of if statement. You can put in snippets if you want. I'll let you mess about with that. I tend to just type it anyway, as you can probably tell. Right, so if it's not game over, we also draw the game. But what if that boolean is true? What if it is game over? Well, that's an else statement. We want to update game over screen, which doesn't exist, so we generate it. And the same here. If you are at the game over screen, draw game over. And let's generate that as well. So what do we actually put in there? Draw game over, for instance. Sprite batch.begin, sprite batch.end. What is that going to draw? Well, I'm going to show you a slightly more complicated way to draw some text, which does scale better though. But first we'll draw the background. That vector2.0, by the way, that's just a short way of saying new vector2 0, 0. So there's our background. We're going to create a string locally, because we only need it here, called text to draw. And it's just going to store a piece of text. Press P to play. We're also going to create a vector2 which will store the size of that text in the font we are using, which is main font, so we can say main font.measureString. I think we've used that before. So the text to draw is going to be measured in that font. We'll get an X and Y size of the image is going to render for those letters. And finally we will need a position to render it in, which will work out based on a bunch of stuff. The X will be graphics device .viewport .width divided by 2 minus text size, and that's a vector, so we need the X coordinate of that divided by 2. So halfway across the text is where you'll find halfway across the screen. And predictably something very similar for the Y coordinate. So now we've worked out where to draw it. It's quite a long-winded way of doing it, but we could probably refactor that into a method and use it whenever we like. I'll leave that up to you to do if you fancy it. It's probably good to do because we definitely are going to reuse that code at some point. But finally, spritebatch.drawString. Use the main font, use the text we wanted to draw, use the position we figured out, and whatever colour you fancy. Now that's the drawing of the game over. What about the update of the game over? Well, it's not going to do much. It's just going to basically respond to if the keyboard tells us that the P key is down, P to play. And if it is, we set game over to false, so it's no longer at the game over screen. We spawn the ball, we spawn the bat, set lives to 3. And once you've got a score, that will probably be set to 0 in there. Almost done with this part at least, but now we've got a game over screen, we should probably go to it when you're on out of lives. That happens during the gameplay, of course. There's lives -1. We could do it here, but in theory there might in future be other ways to lose lives, so I'm going to separate it out and say if lives is less than or equal to 0, just in case, you never know when things might go barmy. Then game over becomes true. Alright, let's give that a shot. There we go, press P to play. If you move around, the ball moves around. Does it bounce off the bat? Yes it does. And when it goes off the screen you lose a life, it respawns, you run out of all your lives, and it should go back to the game over screen. There we go, press P again, starts a new game, bat and ball in the middle, lives back to 3. That mainly leaves the score and the bricks themselves, which is obviously the main bit. Bricks will be made up of an array, so that's what we're really here to integrate, is arrays and loops into your code. And I think I'll do that in the next video. Thanks.